Now the distance formula there is something we have not seen yet. The distance formula actually pops up on page 204 in your math textbook. What the distance formula says is I'm supposed to subtract the x values and square that result, add that to the difference of the y values and square that result, and then I'm supposed to take the square root of the whole thing to find out how long that line is that runs diagonally across the coordinate grid. So we're talking about 0, -2, and 3, 3 here. So we need to subtract the x values here, as this formula shows us in the beginning. So that's 3 minus nothing. And then I have to subtract the y values. Now, since I did this one first and then this one second for the x's, I have to again do this one first for the x's and this one second, or for the y's rather. I have to do this one first for the y's and that one second. All right. Again, I'm following the same order that I used for the x's. I don't want to mix it up and go the opposite direction here. So I'm going to do 3 minus -2 and square that result. And remember, I still have to take the square root of that whole thing, but we have some computation to do. We've got 3 minus nothing, that's 3, and 3 minus -2 is 5, and both of those have to get squared. Remember, I'm doing order of operations here, which I don't think needed to be said, so I'm doing parentheses first, then I did the exponents. All right, so that's going to make me do 9 and 25 here. I'm going to add those up and take the square root, which is the square root of 34, which is exactly what you can see they've done here. Square root of 34 is not a perfect square root, so a calculator would be in order here, and we get 5.8 as a close approximation. That's actually one of those numbers that when we calculate it will take up the whole screen, but we've truncated our answer down to the tenths with a little bit of rounding there, and we come up with 5.8. So that long is 5.8, and since there's no unit given here, 5.8 just units long. All right, so since all the sides are now different, being 3, 5, and 5.8, we can prove what they really wanted us to prove, that the triangle is scalene. So this triangle, as drawn, is a right scalene triangle. All right, let's go ahead and continue on with the next example here. All right, in example 2, we're asked to find the coordinate of each missing vertex. They're telling us that triangle ABC has a right angle at C and that AC equals 2. Okay, so this actually has a couple different possibilities that we can go with here. What they're telling us is that where point C is right now is going to have to create a right angle. Now what they don't tell us is which direction that right angle has to be created in. So the right angle can go up or north, or it could go down, which would be south here. All right, they tell us then that that's going to connect out to point A, and that the line called AC has to be 2 units long. So we make our right angle, and let's start off by going north. Well, I make my right angle going up, there's my right angle, and the line that I'm making has to be 2 units long, because right here that's what they're telling us. So I go up another jump there for the second unit. All right, there's point A, and I connect A and B obviously, and there's my triangle. Now that's just one option here. Again, as I said in the beginning, we could also move south with this one. If I decide to move south with this one, I'm making a right angle still at C, but instead I'm going down 2 units, which would still satisfy their criteria because they never said how long, which direction this has to go. And then I connect And I get my triangle shown in blue with the triangle facing down. Alright, so now we've drawn the triangle. Now the question is, what are the coordinates of point A? Well, if we look at the one where point A is at the top, as you can see, it landed there at 4, 0. Remember, the first number is an x-coordinate where it matches up with the axis that runs left-right. The second number is 0 where it matches up with the y-axis, the numbers going up and down. And that's exactly what you can see that's presented to you right here. If we look at the one where it's drawn down, well, it's still at 4 on the x-axis, but it's not at 0 on the y-axis. As you can see, it's down here at -4 on the y-axis, and that's the answer that's presented to you right there. Okay, let's go ahead and continue on with example 3. They're asking us to find the coordinates of the midpoint AB. Now, the midpoint is something that is initially presented in this very section. So when you look at your textbook for Chapter 7, Section 5, and it happens to be on page 354 in the textbook, you can see the formula and how it works out if you need to. The formula is actually presented to you on the screen right now as well. The formula is the very first line that they give us right there. The formula is actually pretty easy to work with because it's really just a bunch of averages. What they're saying is you take the x-coordinates and add them up and divide by 2. Take the y-coordinates and add them up and divide by 2, which of course would just be the mean. And that will find the midpoint of AB. Now, let's be clear. What would be the midpoint? The midpoint is the point that's exactly halfway between the two endpoints on the line segment. So exactly halfway between A and B as drawn would be the midpoint. Now, if this was a line that ran parallel to the grid lines, rather horizontally and vertically if you want to think of it that way, it would be really easy because we would just count off the number of jumps, divide that in half, and land on that point, and that would be our midpoint. Unfortunately, unless it goes perfectly across a grid box, perhaps, it would be a lot tougher to do that with lines that run diagonally. And really, this formula is so easy to work with because if you can do mean, if you can add and you can divide, you can easily find the midpoint. So, start off here, let's identify what the coordinates are of our endpoints. So point A here, I don't have to go right or left to get to A, but I do have to go up 2 to get there. So that's 0, 2. For point B, well, from the origin, I'm going to go 3 jumps to the right and 5 up. That's 3, 5. And now I have all the information I need. Right. Again, the directions say here I'm supposed to add the x-coordinates and divide by 2. So my x-coordinates are 0 and 3, which of course add up to 3, and then I'm going to divide by 2. Well, 3 divided by 2 would be 1 1/2 or 1.5, which is what you can see they've done in the work over here. Then I'm going to add my y-coordinates and divide by 2. So 2 plus 5, which is 7, and 7 divided by 2 is 3.5 or 3.5, which is again what you can see they've done right here. The coordinate point for the answer is just the results you got when you divided the x's, and then comma, the results you got when you divided the y's. They're not doing anything tricky there. The x work matches the x coordinate, the y work matches the y coordinate. Again, add the x's, divide by 2, add the y's, divide by 2. Find the average, you've got your midpoint. And you can kind of verify that visually, although it would pretty much purely be visual. Where is 1 1/2, 3 1/2 on this graph? Well, it's about right there. All right. Well, that does look like it's about halfway between the A and the B point. If we would have gotten a result that say would have been up here, well, that doesn't even look like it would be halfway between A and B. So we would say something's probably not right there. But because the point does look like it's about halfway between A and B, we can stop and say all is good with life. Okay, let's finish this out with the check it out example here. we're supposed to graph the polygon with the vertices Q, negative 2, 3, R, 1, 5, S, 1, negative 2, and T, negative 2, negative 4, and then we're supposed to give the most specific name for the polygon. Okay, so let's blow this coordinate grid up a little bit here so we can hopefully see everything. Okay, so we started off when they gave us point Q, which was at negative 2, 3. So remember, the first number is an x-axis number, so I'm going to go left to negative 2, and then since the second number is 3, I'm going to go up to 3 and put a point. Then I've got point R. Point R was at 1, 5. So from the origin, I went right 1. Again, first numbers always comes from this axis, the one that runs left to right, and then up to 5, which is point R. Point S is at 1, negative 2. So from the origin, I'm going to go right 1 and down 2 and put a dot, which is this point here. And then point T is at negative 2, negative 4. So I go left 2 to negative 2 from the origin. Again, first number always from this axis. And the second number always from the y-axis down to negative 4. Put my dot. As you can see, when I connect my dots here, the shape that's formed, even though maybe it appears like it's kind of standing up and not usually what we expect, that's a parallelogram. And that's really all we have to say about that. We could be a little more generic and say it's a quadrilateral, but really it is a parallelogram. And that will wrap up this video presentation.